Hello all, I am Professor Nitin Jharwade from the Department of Computer Science and Engineering at Gyan Ganga Institute of Technology and Sciences. It is an honor to be with you today to discuss the important and transformative educational approach, that is outcome-based education, commonly referred as OBE. Let us begin. So here is the index of today's presentation. We will begin with an introduction to OBE. We'll compare the traditional education approach with OBE, OBE for undergraduate programs, and then move through the OBE framework, levels of outcomes, Bloom's taxonomy, and implementation of OBE at Gyan Ganga Institute of Technology and Sciences. We will also cover the benefits of OBE for students. So let us start the introduction. Outcome-based education is a student-centered learning approach that focuses on what students are expected to learn and achieve by the end of the course or the program. Instead of concentrating solely on content taught or time spent in the classroom, OBE emphasizes measurable outcomes such as knowledge, skills, attitude, values students should acquire after learning. In outcome-based education, the phrase product defines process means that the expected learning outcomes determine the entire educational process. This approach starts by defining what students should be able to do upon completion of the program and then works backward to design the curriculum, teaching methods, and assessment strategies that best help the students achieve these outcomes. Let us compare the traditional educational model with the OBE model. Unlike the traditional approach, which focuses on the content and time spent in the classroom, OBE focuses on measurable learning outcomes. If we compare on the basis of focus, the traditional model focuses on what the teacher intends to teach, while OBE focuses on what student is expected to learn and demonstrate. If we compare it on the basis of curriculum design, then traditional curriculum are generally rigid and standardized, but the OBE curriculum is flexible, designed around the outcomes and allow for adjustments to meet the learning goals. With respect to teaching approach, traditional education follow a fixed syllabus and time-based progression, whereas the OBE adopts the teaching process according to learning outcomes and student needs. If we talk about the assessment, the traditional education often assesses the student based on the memory and examinations. In contrast, the OBE uses continuous and varied assessments based on the outcomes such as assignments, midterm examinations, presentations, projects, and practical applications. If we talk about the success definition, the success in traditional education is defined by how much content is covered, whereas in OBE, success is measured by the degree to which the learning outcomes are achieved by the students. If we compare both on the basis of learning responsibilities, then in the traditional approach, the teacher holds the primary responsibility for teaching, while in OBE, students are encouraged to take active responsibilities for their learnings. So these are basic differences between the traditional view and the OBE view. Let us discuss OBE for undergraduate programs. Undergraduate engineering programs under OBE are designed to impart knowledge, skills, qualities which prepare graduates to meet industry and societal needs effectively. If we talk about the knowledge, it means the graduate must have basic information, theories, facts, figures, descriptions, learning, sciences, etc. If we talk about the skills, the graduate must have goal setting skills, time management skills, reasoning skills, communication and interpersonal skills. And if we talk about the qualities or attitude, the undergraduate must self-motivated, self-confidence, integrity, honesty, optimism, enthusiasm, cooperative, and commitment. Let us discuss OBE framework. This diagram represents the OBE framework, which provides a visual overview of the structured process involved in outcome-based education. The framework typically begins with the vision and mission of the institution by defining program educational objectives known as PEOs, which outline the long-term achievements expected of graduates. These objectives shape the program outcomes termed as POs, which describe the specific abilities and competencies students should demonstrate at the end of the graduation. Next, course outcomes, that is COs, are developed which detail the specific knowledge, skills, and attitude that students must attain by the end of each course. These COs are mapped to POs. The teaching learning process, TLP, plays a central role in implementing the framework. It includes lesson planning, delivery of content, assessment, and feedback mechanisms. All are designed to help students achieve the desired outcomes. Finally, the framework incorporates continuous assessment and improvement. The achievement of COs and POs is periodically evaluated using various assessment tools, and feedback is used to refine the curriculum, teaching methods, and learning activities. In summary, the OBE framework follows a systematic cycle of defining outcomes, implementing teaching learning strategies, assessing performance, and making improvements to continuously enhance student learning and program effectiveness. That is, plan, do, check, and act. Let us know the levels of outcomes. There are 4 levels of outcomes in OBE, from broad program educational objectives to specific course level outcomes. First, we will discuss program educational objectives. These are broad statements describing the long-term accomplishments that graduates are expected to achieve within a few years of graduation. They are generally aligned with the institution's vision and mission. Next, we will discuss program outcomes. Program outcomes, known as POs, these outcomes represent the specific competencies that student must demonstrate by the time of graduation. They cover knowledge, technical skills, professional skills, and behavioral attributes. Next, we will discuss program specific outcomes, PSOs. These are the statements that describe the specific competencies and technical skills related to the particular program or discipline. PSOs are tailored to the department's specialized focus area and help in bridging the gap between academic learning and industry requirements. Lastly, course outcomes, COs. These are precise and measurable statements specifying the knowledge and skills that students are expected to acquire at the end of the particular course. Each course has several COs mapped to relevant POs and PSOs. This layered structure ensures that the learning process flows from broader institutional goals down to the specific classroom level learning objectives. The hierarchy helps in tracking student progress, aligning curriculum design, and maintaining quality assurance across all levels. Let us discuss program educational objectives, PEOs. These are program specific. These are 3 to 4 in numbers for each program. These statements describe the career and professional accomplishment of the graduates, which can be achieved in 4 to 5 years after completion of their graduation. After graduation, that is completing the academic program successfully, the candidate or student will start his or her professional career in the field. Afterwards, he or she will develop skills and expertise in their role and will achieve the significant career milestone. This whole process may take 4 to 5 years after graduation. Let us discuss program educational objectives, PEOs. Here are PEOs focusing on technical proficiency, professionalism, lifelong learning, and societal contributions. PEO 1. Graduates will pursue their career in global domain for software development with proficiency in analysis, design, coding, testing, development, maintenance of system, and application software. PEO 2. Graduates will demonstrate professionalism with effective communication skills, leadership qualities, teamwork, ethical, economic, cultural, environmental issues related to multidisciplinary projects for resolving social issues. PEO 3. Graduates will enhance knowledge and skills through higher studies and lifelong learning new computing technologies for attaining professional excellence and research. PEO 4. Graduates will drive scientific and societal advancement through technological innovation and entrepreneurship. Let us discuss program outcomes, POs. POs are what graduates of any engineering program should demonstrate at the time of graduation. POs relate to knowledge, skill, qualities that student is expected to acquire through the program. Now, there are total 12 POs. Out of 12, 5 are disciplinary outcomes. They are specialized expertise in the engineering discipline, and the remaining 7 are professional outcomes, that is generic skills applicable across various professions. Let us discuss program outcomes which are directly related to engineering skills and are known as domain dependent. They are 5 in count. PO1 is engineering knowledge, PO2 problem analysis, PO3 design and development of solutions, PO4 conduct investigations of complex problems, and PO5 modern tool usage. These 5 POs lays the foundation of engineering education. They are vital to the engineering profession and are highly important. Let us discuss program outcomes which are related to engineering skills and are domain dependent. First is PO1. The domain is engineering knowledge. Apply the knowledge of mathematics, science, engineering fundamentals, and an engineering specialization to the solution of complex engineering problems. PO2 is problem analysis. Identify, formulate, review research literature, and analyze complex engineering problems, reaching substantial conclusions using first principles of mathematics, natural sciences, and engineering sciences. PO3, design and development of solutions. Design solutions for complex engineering problems and design system components or processes that meet the specified needs with appropriate consideration for the public health and safety and the cultural, societal, and environmental considerations. PO4, the domain is conduct investigation of complex problem, use research-based knowledge and research methods including design of experiments, analysis, and interpretation of data and synthesis of the information to provide valid conclusions. PO5, the domain is modern tool usage, create, select, and apply appropriate techniques, resources, and modern engineering and IT tools, including prediction and modeling to the complex engineering activities with an understanding of the limitations. Now let us discuss program outcomes that is related to non-engineering skills. They are also known as domain independent. These are 7 in count. They deal with the soft skills, life skills, lifelong learning, and managerial skills. PO6 is related to the engineering and society. PO7 is related to environment and sustainability. PO8 is related to ethics. PO9 is related to individual and teamwork. PO10 is related with communication. PO11 is related to project management and finance. And PO12 is related to lifelong learning. Now let us discuss all the non-engineering POs in detail. PO 6. The domain is the engineering and society. Understand the impact of professional engineering solutions in societal and environmental context and demonstrate the knowledge of and need of sustainable development. PO 7. The domain is environment and sustainability. Apply the ethical principles and commit to professional ethics and responsibilities and norms of the engineering practice. PO 8. The domain is ethics. Function effectively as an individual and as a member or leader in diverse teams and in multidisciplinary settings. PO 9. The domain is individual and teamwork. Communicate effectively on complex engineering activities with engineering community and with society at large, such as being able to comprehend and write effective reports and design documentation, make effective presentations and give and receive clear instructions. PO 10. Domain is communication. Demonstrate knowledge and understanding of the engineering and management principles and apply these to one's own work. As a member and leader in a team to manage projects and in multidisciplinary environments. PO 11. The domain is project management and finance. Recognize the need for and have the preparation and ability to engage in independent and lifelong learning in the broadest context of technological change. PO 12. Lifelong learning. Apply reasoning informed by the contextual knowledge to assess societal, health, safety, legal, and cultural issues and the consequent responsibilities relevant to the professional engineering practice. Let us discuss course outcomes, COs. These statements indicate the knowledge, skills, and qualities, KSQs, which the students are expected to know and demonstrate as a result of learning at the end of course. First, we define the 5 units of content for the course, match each unit with a specific course outcome, and create observable and measurable course outcomes. We apply Bloom's taxonomy and write COs at higher cognitive levels. Finally, students demonstrate the expected knowledge and skills. Let us discuss Bloom's taxonomy. Bloom's taxonomy is widely accepted framework for categorizing educational learning objectives into levels of complexities. Bloom's taxonomy is divided into 6 cognitive levels. The level 1 is remember, which represents the ability to recall facts and basic concepts. Level 2 is understand, which represents the ability to explain ideas or concepts. Level 3 is apply, which specifies the use of information in new situations to solve the problems. Level 4 is analyze, which represents breaking down information into components to understand its structure. Level 5 is evaluate, which represents making judgments based on criteria and standards. The 6th level is create, that represents putting information together in new and innovative way to create original work. Here in Bloom's taxonomy, lower levels focus on the fundamental skills like remembering, understanding, while the higher level promote critical thinking, problem solving, and creativity. By integrating Bloom's taxonomy, we ensure that our teaching strategies are aligned with the desired learning outcomes and the students progress through increasingly complex levels of learning. This is how outcome-based education has been effectively implemented at Gyan Ganga Institute of Technology and Sciences. We follow a structured approach to OBE, ensuring that all academic activities are centered around well-defined learning outcomes. Now, in the process of implementing OBE at Gyan Ganga Institute of Technology and Sciences, we first define outcomes and then we design and follow the curriculum which is mapped with POs, PSOs and COs to ensure the outcome-based delivery. Afterwards, we use teaching learning process, that is known as TLP, which includes effective teaching methods, encouraged learning, and integration of labs to achieve the desired outcomes. Continuous assessment and evaluations are conducted to measure the CO attainments. Also, feedback is regularly collected and used to improve teaching practice and curriculum. Detailed documentation and monitoring is done by maintaining course files, CO attainments, and feedback reports. Now let us discuss teaching learning process TLP in detail. The teaching learning process TLP is the core to academic success in engineering education. With the implementation of outcome-based education, TLP must align teaching strategies, learning activities, and assessment methods with clearly defined learning outcomes. We follow a structured approach to effectively implement TLP in Gyan Ganga Institute of Technology and Sciences. This is the first step of teaching learning process under outcome-based education, that is defining learning outcomes clearly. Define clear and precise course outcomes, COs, is critical to the success of OBE. These outcomes specify what students are expected to know, perform, and demonstrate by the end of the course. First of all, COs are formatted using Bloom's taxonomy to ensure alignment with the appropriate cognitive levels such as understanding, applying, analyzing, and creating. The outcome must include action-oriented, measurable verbs like understand, apply, analyze, and design to specify the student capabilities. Afterwards, each CO is carefully mapped with the relevant POs and PSOs to ensure that every course contributes to the overall program goals. Afterwards, the outcomes are designed to be realistic, achievable within the course duration, and focused on both technical knowledge and transferable skills. For example, if we talk about the subject machine learning, then CO1 is the understand and apply basic of ML, including data types and models, which maps to PO1, that is engineering knowledge. Next, curriculum design and planning. Once course outcomes are clearly defined, the next step is to develop a well-structured curriculum that ensures these outcomes are met effectively. For that, first we do syllabus mapping. Each unit of module of the syllabus is mapped to relevant COs to ensure comprehensive coverage of all the intended outcomes. Then we prepare the detailed lesson plan, which includes learning objectives, teaching methods, and assessment tools. Afterward, documentation is done. For that, use of structured templates such as lesson plans and course files for systematic documentation and easy tracking are maintained. Also, the academic calendar is integrated for the effective time management and smooth course delivery. Now next is adopt effective teaching method. We employ a variety of teaching methods ranging from chalk and talk to the recent advancement in effective teaching methods. So the methods used are chalk and talk, PowerPoint presentation, problem solving sessions, lab-based learning, project-based learning, ICT tools and LMS like Moodle, then flipped classrooms, demonstrations, case-based learning, peer teaching, gamification, and think, pair, share techniques. Next is encourage active learning. Active learning is an institutional approach that actively engages students in the learning process beyond traditional passive listening. This active learning is achieved through group discussion, case studies, peer learning, problem-based learning, flipped classrooms, and role plays and simulations. Next is laboratory and practical integration. We emphasize the critical role of laboratory and practical work in the teaching learning process. Laboratory sessions and practical assignments allow students to apply theoretical knowledge in real-world scenario, enforcing their understanding and skill set. The laboratory and practical integration is achieved through integration with theory, hands-on practices, mini projects, outcome-based manuals, collaborative learning, and assessment and feedback. Now let us discuss assessment and evaluation. We conduct continuous formative assessments such as home assignments, assignment tests, and vivas. Also, summative evaluations through mid-semester and end-semester examinations. Rubric-based evaluations are done for the projects, and each question or task given in the assignment or any examination is mapped with CO and marked accordingly. If we talk about the assessments, there are two basic categories. One is internal assessment and another is external assessment. And these assessments are carried out for both theory and lab. If we talk about the internal theory assessment, it includes home assignments, assignment tests, continuous assessments in the form of the midterm examinations, then quizzes and attendance. And if we talk about the external theory assessment, it is actually performed or carried out using in-semester examination. On the other hand, if we talk about the lab assessment, then the internal lab assessment is achieved through the practical record maintenance, execution of program outcomes, vivas, and record submission. On the other hand, external lab assessment is done through the external in-semester practical examination. Now let us talk about the continuous feedback and improvement. We actively collect student feedback for each course through surveys and course end evaluation on teaching effectiveness, relevance of content, and learning support. We analyze the feedback and modify the teaching methods, content delivery, and assessment based on the feedback. We review CO attainment reports and take corrective actions to improve the outcome. Documentation and monitoring. Proper documentation is essential for maintaining academic transparency, ensuring regulatory compliances, and enabling continuous improvement. For this, key documentation includes course files, assessment records, COPO attainment reports, and feedback. The course file itself includes the approved syllabus, detailed lesson plan, course outcomes mapped to program outcomes and program specific outcomes, sample assignments, question papers mapped with COs, and records of student performance and attendance. The assessment records are the detailed records of all assessment tools such as quizzes, assignments, project evaluations, lab reports, and examinations are maintained for every course. If we talk about COPO attainment reports, faculty analyze course attainment levels and prepare COPO attainment reports to evaluate the extent to which students have achieved learning outcomes. If we talk about feedback reports, records of feedback collected from students, alumni, employers, and faculty members are maintained to identify areas for course and program improvement. In continuous monitoring, academic progress is continuously monitored through internal audits, faculty reviews, and academic committee evaluations. In essence, effective documentation and monitoring provide a strong foundation for quality assurance and academic excellence in the OBE framework as per NBA norms. Now let us discuss faculty development. Faculty development is crucial for ensuring effective implementation of TLP and continuous quality improvement in engineering education. It enhances the industrial competencies, technical knowledge, and pedagogical skills of faculty members. In Gyan Ganga Institute of Technology and Sciences, faculty development is achieved through induction programs. We organize orientation programs for newly recruited faculty covering OBE principles, curriculum delivery, assessment practices, and institutional policies. Then we organize workshops and trainings. Regular workshops on modern teaching methodologies, digital tools, active learning strategies, and Bloom's taxonomy are organized in the college. Then We organize faculty development programs, FDPs. Faculties attend intensive training programs focusing on emerging technologies, research methodologies, and advanced teaching approaches. These FDPs are organized by the national and international level organizations or institutions like NPTEL, IITs, NITs, IIITs, etc. Certification programs. We encourage faculty to pursue national and international certifications in specialized technical domains and educational technologies offered by NPTEL, Google, Cisco, Oracle, AWS, Red Hat, Wipro, etc. Research and consultancy. We promote participation in research projects, paper publications, patents, and consultancy activities. Collaborative learning. We establish teaching circles and communities of practice for sharing innovative teaching techniques. Industry interaction. We do faculty internships, industry visits, and collaboration with industry experts to stay updated with current trends. Lastly, performance appraisal. Periodic evaluation of teaching effectiveness through student feedback and peer reviews to identify areas of improvement. In TLP, industry and alumni integration is important. We foster partnerships with industry and alumni to bridge academic learning with practical and real-world application. We organize guest lectures and seminars by industry professionals. We arrange industrial visits and internships for students. We collaborate with industries for joint research, projects, and curriculum development. And we seek inputs from alumni for continuous curriculum enhancement. In TLP, the role of faculty is very much important. Through effective course teaching learning activities, the faculty of Gyan Ganga Institute of Technology and Sciences interact with industry experts, identify the industry relevant knowledge, skills, and qualities, facilitate active learning, make course students ready for industry, imparting relevant KSQs, and ensure that the identified KSQs are demonstrated by course students through a valid and reliable assessment. Finally, let us discuss benefits of outcome-based education for students. The first benefit may be clarity of expectations. Students clearly understand what they are expected to learn and achieve through well-defined learning outcomes. Skill-oriented learning focuses on acquiring practical skills and competencies relevant to the industry, making students more job ready. Enhanced critical thinking encourages enhanced critical thinking, which encourages higher order thinking through problem solving, analysis, and project-based learning. Self-paced learning. Students can learn at their own pace, revisiting concepts until they master them, especially with blended learning methods. Active participation. Students are actively engaged in the learning process through group work, presentations, and discussions. Improved academic performance. Continuous assessment and feedback help students improve progressively throughout the course. Career readiness. Students are better prepared for professional careers with outcomes linked to employability and lifelong learning. Personalized feedback. Regular assessments and evaluations provide students with individualized feedback on their strengths and areas of improvement. Global competence aligns learning with international academic and industry standards, promoting global mobility. Confidence and motivation. Clear achievements and measurable progress boost student confidence and motivation to learn. To conclude, outcome-based education empowers students to achieve success not just in academics but in life and career. Thank you.